everyone, Leo here from Apicoo Robotics. In this video, I will show you how to integrate the SusGrip gripper with the Thor 7 robot arm from Agile Robots. When you receive the SusGrip package from Apicoo, it always comes with the following components: one SusGrip gripper unit, 2 default fingers for the 2F variant, or 3 fingers for the 3F variant. For each finger, you get 2 dowel pins and 1 M5 bolt for fingertip mounting. You also get 4 M5 bolts for attaching the gripper to the robot end effector, 1 SusGrip cable, and 1 USB to RS485 converter device. Depending on what was requested at the time of purchase, the package may also include customized fingertips for specific applications, a customized tool flange for the Thor 7, customized cables for non-standard I/O ports, and a USB flash drive containing documents and control software. Once you have confirmed all components are present, we can start the assembly. Start by inserting the 2 dowel pins into the 2 designated holes on the SusGrip base. Then place the fingertip on top, aligning its holes with the 2 dowel pins. Once aligned, secure the fingertip with 1 M5 bolt and tighten to a maximum torque of 3 Newton meters. Repeat this process for all fingers, twice for the SusGrip 2F and 3 times for the SusGrip 3F. Now we can mount the gripper onto the Thor 7. In this demonstration, we are mounting both a SusGrip 2F and a SusGrip 3F simultaneously, so we use a custom dual mount adapter flange. This flange is not included in the integration package. You can either fabricate it or order it from Apicoo at purchase. Start by placing the adapter flange onto the Thor 7 end effector tool and securing it with 4 M5 by 10 bolts. Use up to 3 Newton meters of torque to tighten the M5 by 8 bolts. Next, mount the SusGrip 2F onto one side of the adapter flange and secure it with 4 M5 by 10 bolts. Give it a firm check to make sure it is properly seated. For the SusGrip 3F, an additional adaptive sub-flange is needed. Attach this sub-flange to the bottom of the SusGrip 3F first, using 4 M5 by 10 bolts. Then lower the assembled unit onto the second position of the adapter flange. Align the holes and fasten securely. Inspect both grippers to confirm there is no play or misalignment. With the grippers installed, we can move on to the wiring. Begin by connecting the SusGrip cable to the gripper. Make sure the connector key is correctly aligned before inserting. There are 2 communication interfaces to wire up: RS485 for Modbus RTU control and Digital I/O for signal-based control. We will go through both. For the RS485 connection, you can use the physical RS232/485 port on the Thor control box. For this, you need a DB9 male terminal block. On the open end of the SusGrip cable, connect the yellow wire to pin 4 or pin 6 on the DB9 connector. Connect the green wire to pin 1 or pin 9, then connect the red wire to the 24-volt supply and the black wire to ground. Once the terminations are done, insert the DB9 block into the RS232/485 port on the controller. The second method uses the USB to RS485 converter included in the package. The wiring logic is the same, but for detailed wiring diagrams, refer to the SusGrip main manual. For the Digital I/O connection, locate the blue, brown, orange, red, and black wires on the open end of the cable. On the Thor control box, configure the universal I/O terminals as follows. Connect the digital output COM directly to positive 24 volts. This provides the sourcing voltage for gripper commands via the blue wire. Connect the blue wire to a digital output channel. Connect the brown wire to a digital input. This carries the gripper's motion status signal. Connect the orange wire to a separate digital input. This carries the object detection and grasp success signal. Finally, connect the digital input COM to 0 volts so the DI ports can sync the 24-volt PNP signals coming from the gripper. Power connections for red and black are the same as described for RS485. In our setup here, we connect both the RS485 and the Digital I/O interfaces at the same time. This lets us switch between Modbus mode and I/O only mode without any rewiring. You can use the Thor internal universal I/O supply for power. However, we recommend connecting the gripper to a separate dedicated 24-volt DC power supply. Now that the hardware is ready, let's set up software control. Controlling SusGrip through the graphical interface on the Thor Teach pendant is recommended for ease of use. A USB flash drive contains all the Python scripts you need. Insert the drive into the upper left port of the Teach pendant. The system will detect it and display it in the file directory. To import a script, go to the Programming section from the main menu. Select Python script, then click Import. Browse to the directory where the USB drive is located, press Previous multiple times, then tap Media. Next, tap through the subfolders until you reach the script file. Select the script you want. A notification will appear to confirm the import was successful. Repeat this process for any other scripts you need. Now, one important thing to keep in mind when working with multiple scripts: if you need the same type of command but with different target values in a single program sequence, you need to create separate, independent copies of the script, and each copy must have its internal code modified accordingly. Here's how to do it correctly. First, go to Settings in the top right menu bar, open the File System tab, and navigate to the Python folder. Select the script you want to duplicate, tap Copy, then Paste. A dialog box will appear, then enter a new name that clearly reflects the intended target value. For example, sg-set ssaf-50.py, where 50 represents a 50mm opening distance. Press OK to confirm, then double-click the rename file to open it in the text editor. Find the relevant Python variable. In this case, target_POS or value depends on the script, and change it to your desired value. Tap Cache to save the changes, then Cancel to close the editor. To operate the SusGrip in I/O-only mode, we first need to import a mode switching script onto the Teach pendant. Go to the Programming section on the main menu, select Python script, then click Import. Follow the import step that was mentioned before, then select the script named 9_SG_set mode and confirm with Select. A notification will appear confirming the import was successful. To configure the script, click Select to open the list of imported scripts, then double-click 9_SG_set mode to open it. Click Edit Script to view the Python code. Find the value parameter and set it to 0 for normal mode, or 1 for I/O-only mode. Once done, tap Cache to save the change, then close to return to the previous screen. To execute the script, tap the play icon and select Run from Begin. For I/O-only mode setup, add a set block at the desired point in your program sequence. Set the type to external output type, then select Digital Output. Choose the specific DO pin wired to the SusGrip, in our case, board.do0. Assign high to trigger the open action and low to trigger the close action. Using a wait node to wait for the gripper to finish its motion before the robot proceeds to the next move. To set this up, go to the Programming tab under the Components menu and tap the wait icon to insert a wait node. Under Type, select Condition Delay. Set the condition source to digital input, then choose the port connected to the gripper's motion status output wire, in our case, board.di1. Assign the target state to high or low based on the gripper's action. For example, when the gripper changes its motion from 0 to 1, which is close to open, then choose the target state to high to wait for the gripper to finish its opening motion. The program will pause at that step and only continue once the digital input matches the specified logic. That's everything you need to integrate the SusGrip with the Thor robot arm. If you have any questions, feel free to reach out to us via email. Happy commissioning!